Good evening, everyone. I hope I'm audible. Thank you. I'm Diana, PR and Outreach Manager of the AWS Cloud Club at St. Joseph Group of Institutions. It is my pleasure to welcome you all to episode 6 of a workshop series organized under the PEP Cloud Computing and DevOps Center. Today's session, AWS Meets Docker, a workshop on containerization, promises to be an exciting and highly informative deep dive into the world of Docker, led by our talented speakers Sakshi, Ravi, and Mohana, Priya. Both of them bring with them a wealth of knowledge and expertise in cloud technologies and containerization, and we are thrilled to have them guide us through the session. In this workshop, you will have the opportunity to explore how Docker, a leading containerization tool, integrates seamlessly with AWS, helping you all to streamline and modernize application deployment processes. On behalf of the AWS Cloud Club and St. Joseph Group of Institutions, I extend a warm welcome to our speakers and participants. We look forward to an engaging and insightful session. Thank you, and let's dive into the world of containerization.
Yeah, thank you, Diana, for your beautiful welcome. Am I audible?
Yeah, you are.
Okay, so let's start the session. Before that, let me share my screen.
Folks, please turn on your cameras. And for just a note, if you have like missed this part of session, you can go check in our AWS Cloud Club YouTube channel. The link will be given in the chat box.
Okay, is the screen visible to everyone?
Yes, it is.
Okay, so today we are going to learn about Docker. So our agenda is like we'll have an introduction to what is Docker, what is a container, what is an image, and then we'll get into the session like what is the difference between Docker and virtual machines, and then we'll see what are the Docker commands and how are they used, and then what is a Docker file, Docker network, Docker volumes, and Docker compose. At last, uh, a project demo will be shown by my friend Sakshi Ravi. So, fine. Docker is like an open source containerization platform that packages the application with all the necessary dependencies into a standardized unit called containers. So, whenever you have a application, it will not be compatible with all the operating systems, like its dependencies. If, like, how could I say, its databases, and then the softwares that are necessary to build that applications and all. So that's why we use Docker to containerize the application with all the necessary dependencies it wants. So, so these necessary dependencies are containerized into a standardized unit called containers. These containers are light in weight so that it can be easily portable, and also these containers are isolated from other containers. Well, these applications are packaged into dependencies, right? So the application that is packaged along with the dependencies is said as a Docker image. So basically, to say what is a Docker image is nothing but it is an executable package of software that is needed to run an application. So all of you might have a question that what is the difference between a Docker and a virtual machine, right? So can anyone unmute yourself and say what is the difference between a Docker and a virtual machine? Guys, am I audible? Any one difference is enough for me. Yes, sir. You have raised your hand.
So I don't know the difference, but VMs are very old and Docker seems very new. So I'm wondering, are VMs harder to set up and Docker makes it simpler? Is that the difference?
Um, Fine. So basically, what you have said is correct, sir. Fine. Let's dive deep into the difference between Docker and virtual machine so that you'll get an idea about what is Docker. So as I already said, applications have dependencies, and Docker helps us to package the application with all the dependencies it have into a unit, into a like portable unit called container, right? On other hand, virtual machine, it is an emulation of a physical container on the host machine. Uh, by emulation, I am saying that we used to imitate how a physical computer looks like. So, right. Let me show the image so that you can get an idea. So if you see here in virtual machine, here is the hardware and here is the host operating system. And then VMs have their own operating system on top of the hypervisor, and and then it has its applications in that VM instances. So when it comes to Docker, you have the hardware, the host operating system, and on top of the host operating system, the Docker has the application layer along with its dependencies. So here, when it comes to virtual machines, it just imitates how exactly the physical computer looks like. But when it comes to Docker container, it just virtualizes the application layer and runs that on top of the host operating system. So that is what the second difference is. So Docker container just virtualizes the application layer and runs on top of the operating system, host operating system, and virtual machine virtualizes both the operating system kernel and application layer. Here, if you see, this is the operating system kernel and this is the application layer. In VM instances, virtualizes these both things, whereas in Docker, it just virtualizes only the application layer and runs on top of the host operating system. Okay. So how Docker helps us? Since it only virtualizes the application layer, Docker containers are light in weight and it does not take much space. But in context of virtual machines, it virtualizes both the operating system and the application layer. So it will be larger in size and also occupies more space. So Docker is compatible with any Linux distributions, whereas VM has its own OS and it is independent from the host OS, so compatible with all the operating systems. As I said already, Docker is going to run on the host operating system. So mostly Docker use Linux distributions. So it is so compatible with the Linux distributions. Uh, it doesn't mean it does not support Windows, but it has some issues when it comes to Windows. Okay, but in context of VM, it has the host operating system is here, and the guest operating system is completely independent from the host operating system. So it is not going to affect the host operating system. And then Docker image is light in weight, whereas VM is very large. And I said this point previously. So, since Docker images are light in weight, they can start within a few minutes, whereas VM instances are large in size, no? So it takes some time to start a VM instance. Okay. So, still now, am I clear? Do you have any doubt in that?
It's
No.
clear to me.
Does anybody? Everyone. Okay, fine. Shall I continue? Okay. So if you have any doubt, you can stop me there itself and you can ask me. I'm ready to rectify to the best of my knowledge. Okay. Okay. So this is what the difference between a Docker and a virtual machine. Okay. Now let's get into the Docker commands. So first we'll look how what are the functions of this Docker commands, and then we'll get into the hands-on lab. Okay. So first of all, Docker pull. So you might have a question that I am saying Docker images, right? Do you have any guess that where these Docker images are stored? Yeah, anybody else? Yes, somewhat similar, sir. Docker website. Actually, Docker has a public repository called Docker Hub. So there we will publicly store the Docker images, and anybody can pull that images into their local system and then run the images. Okay. So similarly, we have private repositories also, like Elastic Container Registry that is provided by AWS, Google Container Registry that is provided by Google Cloud Platform, and similarly Azure also provide a private repository for storing these Docker images. Okay, am I clear? Okay, shall I proceed? Okay, fine. So Docker pull command pulls the images from the Docker Hub. So make note of this. It only pulls the image from the Docker Hub. So and then Docker run command. If you give Docker run command, it pulls the image. If that image is not already pulled and it doesn't exist on your local host, and then runs the count and then runs the container. If the image is already present, if the image is already pulled and it exists on a local host means, then it will directly start running the container. Okay. Docker images. This command is used to see all the images that are pulled from the Docker hub. Okay. Docker ps. This command is used to see all the running containers, and Docker ps hyphen a. This command is used to see all the running as well as stop the containers. Okay. Docker stop command is used to stop a running container, and Docker start command is used to restart the stopped container. Docker logs. This command is used to take logs of a container, and to remove the container we use Docker rm command, and to remove the image we use Docker rmi command. So if you want to know detailed more details about the container, you can give Docker inspect. Okay. Now we'll get into the hands-on. So I'll just put the commands and you can able to guess things. So so this is how the Docker engine looks like. Kindly wait for a few minutes. Let it start. Okay. Okay. Can anyone say what command is used to pull the image from Docker Hub?
Is Docker pull?
Yeah, exactly, Docker pull. So I'm right now going to pull an image. So basically an Ubuntu. Yes. So this Ubuntu image has been pulled. This Ubuntu image has been pulled from Docker Hub. So if you put Docker images, you can see the image name. See, Ubuntu is here. Okay. And then Docker run command is used to run the container. Okay, so I have run the container. If I put docker ps command, it should show my running containers, right? Am I audible? If I put docker command, it should show my running containers, right? So let's see what happened now. See, no container is running. Can anyone say what is the reason?
It might random stop.
Yeah, so basically, an image will not have that much of work, right? It will start and it will stop immediately. If we create any interactive mode, then it will be running continuously. Okay. So unless otherwise we assign some task, it will not be running. Okay, it will start the container and immediately it will exit the container. So if I put docker ps -a, you can see that the container here its status is in exited mode. Okay, fine. And then to open an interactive mode, um, you can put docker run -t ubuntu. So this basically opens the container in interactive mode. Here you can put any Ubuntu commands. It will give all those like it will give the output according to the command. If I put ls, it will give the files that are present in that container. Okay. So to exit, I'll give exit. Right. Um, and then you can also do port binding while running Docker commands. So for that, you will give Docker run -p. So Docker run -p 80:80 Mohana. This is my Docker Hub login name and front end. So what this -p command do is it basically binds the Docker container with the local host port. So if I go to my browser and I put localhost 80, you can able to see my application. See, this is my application. So you can do port binding by using -p command. Okay. And to stop a Docker container, you will give Docker stop container name. So once the container is stopped, it will return the container name as a result, as an output. Till now, do you have any doubt? So shall I proceed next? Okay. So next command that we see is Docker start command. And as I said previously, Docker start command is used to start the stopped containers. So if you see to my Docker engine, you can able to see my container running. Okay. So this is why we use Docker stop command. And then yes, then we are going to see how to remove the container. To remove the container, first you have to stop the container and then you have to remove it. Until otherwise you stop, you can't remove. Okay. Yes. Now the container has been removed. If you go and see, if you see, so there is only one container running. That is my front end container is only running. I initially started the Ubuntu container and it is now stopped. It is now removed. So in order to remove an image, first you have to stop the container and then you have to remove the container and then only you can able to remove the image. So if I give docker rmi ubuntu, yeah, the image has been removed from the docker and the image has been removed. So if you see here, there is no ubuntu image. Okay. So by now, the Docker container names are given by the Docker, right? We can also able to name the container up to our wish. For that, we use Docker hyphen name. See, I have named my container. So this is what and So before I gave a command, I gave the container name as my container, and it showed me some error, right? So uh, basically, what the error mean is, if in that Docker engine you can have containers with unique names only. You can't able to repeat the container's name. Okay, if a container is already running with the name my container, then another container with the same name cannot run. Okay, uh, if we want to make the container run, we have to give the name my container. So
I think her battery has gone down. We'll just give her 2 minutes to reconnect. I think it's taking more time for Mohana to be joining here. So before that, Sakshi, can you please take over the session? Okay, she's here.
Yeah, am I audible?
Yeah, you are.
I'm really sorry because there's no power in my home, and so suddenly my laptop got shut down also. So till now, can you able to understand the commands I said? Is there any doubt? Yeah. Okay. Fine. The next we'll get into the concept of Docker network. Well, Docker network is used to communicate. Docker networks are used to communicate with other containers. Okay, so if one more than one container is running on your host means it may have a necessary to communicate with each other. For that, they will use Docker networks. Okay, not only for the communication between the containers, but also uh, to access the internet, they will use Docker network. Okay, so basically there are six types of network, if I'm not wrong, and we'll see about the three types, which is enough for this class. Okay, the first step is first type is bridge network. So, as I said, Docker is going to run on your host operating system, right? So, your host will have one Ethernet interface address, which, for example, let me say that Ethernet interface address starts with 192.16.34. Okay, so that a container is running on top of your host machine, and this container is having this Docker container will have a separate Ethernet interface address, and for example, let me say that Ethernet interface address of that container is 172.18.31. Okay, so the Docker containers Ethernet interface address is completely different from the host Ethernet interface address, right? So when you try to ping this address, definitely it will show an error. It will show a networking error because these both are completely different. So for that, Docker will provide an virtual Ethernet interface address. This is also known as Docker 0. So this Ethernet interface address is used to communicate with the host. So this is called as bridge network. By default, if you don't specify any network means, by default bridge network will be created, and it helps us to it helps you to communicate with the host. Okay, am I clear? Do you have any doubt in this?
Mohana, no doubts, but can you keep your mic closer? You're not that much audible.
Yeah, yeah, sure, sure.
Yeah, thank you.
Okay. Am I audible now? Am I clear?
Yeah, it's clear. Yeah, it's
Okay, fine. The second type of network is the host network. So, previously you like we saw that in bridge network, the Docker will provide one virtual Ethernet interface with the use of that virtual Ethernet interface, we used to communicate with the host, right? So in host network, the containers will directly use the network of the host. So let's say uh, the host, as I said already, the host network. Yes, the Docker container will bind the bind the port with the host port. Okay, so similarly, the ETH address of the host is completely different, no? So the Docker container will make a port binding with the host port. And the next type is none network. None network will not expose your container to any other to any other to the other host or the network. It will keep your container isolated. Is there any doubt? Let me revise these steps. In bridge network, the Docker container will provide a Ethernet interface. With that Ethernet interface, you will communicate with the host. Okay. So in host network, the Docker container will bind the container with the host Ethernet interface. Okay. And in the NAN network, it will not expose your container to the host or else to the internet. It will make your container isolated. Okay, fine. And Docker volumes. So basically, whatever the data you store in the containers will not persist once you stop your containers. So if you stop your containers and then restart, your data will not be there. Your data will be lost. In order to make the data persistent, we used to create volumes. Okay. In that volumes, we have three types of volumes. One is bind mount. In bind mount, we used to map the directory of your local host to the directory in your container. The second one is anonymous volumes. Anonymous volumes are created and maintained by Docker. So you will not specify any directory. You will not specify any volumes. Okay. And the third one is named volumes. In named volumes, are created by us, and we use created by us and are also and is managed by Docker. Okay, so are you clear in this? So let me hand over this session to my friend Sakshi, and she will show you the demo. Thank you. Is there any doubt? No. Okay, thank you.
Hi everyone, myself Sakshi. So I'll just show you a demo of like how to, I'll just from the uh, comments which Mohana showed you previously, I will just give you like a short demo of how to, run a React application, like how to containerize a React application. So I'll just straight up dive into the hands-on of how to do that. So let me share my screen for a quick bit. Is my screen visible to everyone? Okay. So for Docker to be running, first we all need to have this Docker desktop, which should be running in your desktop. So first I will open this Docker desktop. Because without the engine running, you can't perform any actions. So I'll just start my Docker desktop real quick. Docker open ஆகல சுத்தம் set. Uh, okay. Then I'll just open my VS Code. So I'll just show like how to create a basic React application and how to containerize afterwards. So that I will just open a new folder. So I already created one for this. So I just open that. Okay, so I'll just open a new terminal, and I guess like many of you are sure like how to create a basic React application. So the commands will gonna be like npx create React app, and I'll just name my app like for simple. I'll just name it like first app. So it will just create a app for me like a React application, a basic one. It's taking a couple of minutes. Let's wait for that. So while it's taking its time to run, let's discuss about AWS application in Docker. So AWS is already providing like three services. Like I know, like pretty sure many of you guys are familiar with. It's the ECR, ECS, and the Fargate. So through which we can basically have the Docker container run. The first one is ECR, which is Elastic Container Registry. So this is where you store your Docker images. So this service which is offered by Amazon, it helps you store your Docker images. It's like basically a cloud based storage for images. So you can easily pull them when you need it. So it is basically a Docker hub, like the one which Mohana mentioned. It's basically a Docker hub, but which is hosted on AWS. So that's the ECR thing. We can also store our Docker images in ECR. Uh, okay, so now this React application is created. Okay, yeah, it's created. To check whether my React application is created, there's this simple command. It's npm start. I'll just run it. Okay, so yeah. Then for that, you can see here my I have like a app is created for me. So what I'm gonna do is I'm gonna create a new file, which is a Docker file. So we all do please remember always put Docker with caps key and it's Docker file. So now we'll dive into like what will be the codes which will be having inside the Docker file. So as I said earlier, it's a React application which we're gonna Dockerize. So React application need a Node.js one to run in the background. So first we will just get that one. That is the command will be from Node 14. So it's telling the Docker to start building an image from an existing image that the existing image as a base image. So that will be our first one. So next we'll have the work directory. So work directory means like where I'll type it out. So it's coming work directory. So the one which I'm using here is the app. So it basically tells the just a working directory inside the condition. Think of it as a into a folder name. So this we are directing the Docker file to completely into the app inside the container where the subsequent commands will be executed. So this will be our next line of the code in the Docker file. So next we will just dive into this the third line. So which is used for to copying the package JSON and the package log JSON file. So copy means like we have a local machine, so where the Docker image is running, right? So we'll just type the command copy. So what basically it does is it copies the file from the local machine into the Docker image. So and it copies both package.json. It basically copies the file from the package.json. So I'll just type out the command for it. It's package. I guess you guys are following with me, right? It's am I audible and my screen is visible to all of you? Okay. So it will be best like if you guys follow with me along with me so we can easily Dockerize and React application in a first class. So yeah, we'll go. It's package and to obtain it we will just put a star package star.json. So it will simply copy the files from a local machine into the Docker container. And also we'll put, yeah. So next comes a fourth line of code. So which is run npm install. So what it basically says is that we need to, this run command executes a command which inside the Docker container while the file is being built. Okay, so it basically says that we need to install npm as a package to run a React application. So we are basically telling the Docker to run the npm install command. So this is the fourth line of my thing explains. Next comes the copy. So this is the main part of our code. So which this line, this copy, what it's saying is to copy the rest of the application code which I have created just now. So this copy include this will entirely copy the application code which I have now created. Then we have this command called this run npm run build. So this command is necessary for that. It's a command to build our React app. Okay, so basically we have built a React app, but to build our React app in a Docker, the image to build the image, we need to use this npm run build command. So what it does is that it's a command that builds a React app, and it will optimize all this JavaScript CSS file which is created while creating the React application. Then comes our next line of code. So basically, after this, we need a multi-stage build. Okay, so multi-stage build is nothing but we need a production ready server to run our images. So for this, we are using Nginx. So Nginx is an engine. So it's like the lightest version of web server, which is Alpine. So I'll just type here the code. So we'll just obtain the from and Nginx.alpine. I'm using this because it's a base image, which is a lightest version of Nginx web server. So I'm using from Nginx Alpine. So next comes the crucial part of the code, which is we need to copy the build files from the previous stages because we have already copied many files, we are already installed, and we already run many commands into a run our application. So here comes the copy command. So it basically what it does is copy the build files from the previous stage. So the command says like copy. So from where we are copying is there. So from 0 and from the app we have built. So it goes like app, the one we set it to build. Then we will have a user. Then let's share it one. So it's running in our Nginx engine. So we are coming with the command and the HTML of the file is need to be run. So we are like entirely copying it copies the static file. Okay, so we have basically generated this line of command run npm run build. So it will generate some of the static files. So the static file is this app build share Nginx HTML. So it will basically copies all the file. Yes, sir. Do you have any question?
Yeah, I just wanted to know, like, if you show your code once.
Yeah, sure.
So you mentioned on the line number 8, copy double hyphen from number 0. So
Yeah.
what does this mean, like a double hyphen from equal to 0? If you can explain that, if I have missed.
So this double hyphens like zero basically tells Docker to copy the file from the first stage, from the node, like basically it's run on the Node.js environment, right? So this command says Docker to copy the file from the basic first stage of the thing.
I believe
Hope it,
it is not a multi-staging build, right?
yeah, we're building it for a multi-stage one.
Yeah, I so far I know, like if we use the double hyphen from, that is for the multi-staging building. If we use, since we have not like defined any names, so I am just confused on that. That's what my question was. Thanks.
Okay, thank you. So hope I cleared it somehow. But uh, sorry. So the next one goes like the now we are coming into the stage where we expose our code to the Docker. So this command comes as like expose 80. So basically, what it says is that this expose command, the one you're seeing here, is this. It's tell the Docker which port that the application will use inside the container because Docker like uses different kinds of ports. So when we use this expose command, it tells the Docker which application will be used inside the container. So we have used this Nginx server. So Nginx is uses port 80 by default for web pages. So we are using the port number 80 for here. So next, after completing all this, we need to start off our Nginx server. So the command will be like you're commanding the Nginx server. Um, to first the basic command to start off the server. So just okay, so now we have done that, I guess, engines. So as I mentioned to you guys earlier, so yes, apostrophe system. Okay. Now the command is done and dusted, and I'll just quickly save it. So as I mentioned to you guys earlier, we need a Docker desktop running. So currently I'm unable to open my Docker desktop, but I don't know what's the problem. So please give me 2 minutes while I just open my Docker desktop. If that's not an issue for you guys, I just need 2 minutes to quickly check what's the problem with my Docker desktop.
We are so sorry for the inconvenience that's happening today. She's currently facing problems with her network. Chennai rains have come again and it's like spoiling all our day.
I'm in indoor, and this is the first time I've seen rain in India. It was raining today.
Oh, really?
And 2 weeks in India, no rain. It was so hot in the other countries that it made me sick. It was so hot because I'm not used to this level of heat in the other cities. But here, it was hot, but at least it was raining, so I was very happy. I'm sorry the rains are causing problems.
Yeah, even the heat is not tolerated by us who are staying in Chennai.
It was so hot yesterday, I couldn't believe it. I was in Raipur and it was just incredible. They said it was not seasonal, it was unexpectedly warm. I really enjoyed learning about Docker, but I have to go now. And folks, it's really great to see so many people joining in their evening and learning together. It's brilliant. Keep up the good work. I was impressed by both the presenters this evening, even though there was technical difficulties. That's not your fault. And I really like that there was a very practical, useful thing being presented tonight. I think all students who are doing technical things would benefit from it. So well done. And I think Mohana and Sakshi, well done. I know you're having some technical issues, but that happens to everyone, so don't worry too much.
Thank you for joining us, sir.
Take care,
Thank
folks.
you,
Now,
sir.
I'm actually going to go and meet another captain now in the city I'm in because we're organizing a student community day. So we've lots of work to do for that. Okay. Take care, folks, and take care, everyone.
Thank you so
Thank you,
much
sir.
for your lovely comments. Please do connect us in the next session possible. I'll definitely ping you. Sorry for this technical
N-
errors. It
No
was
problem. I hope I get to visit Chennai in person.
Yes, sir.
And
Please do
sure,
visit.
sure, sure.
if you folks have not connected with me on LinkedIn, everyone on the call, please do so. I would love to connect with you all on LinkedIn, especially our presenters today, so I can send them hard Docker questions when I get stuck.
Sure,
Take care,
sure,
folks.
sir. Thank you for
Sure, sir.
connecting.
Thank you. Thank you for your lovely comments. Thank you so
Please
much.
do
Take care.
visit Chennai too. We'll be so happy to host you here at St. Joseph.
So, hopefully next time it would be great. Take care.
Sure, sir. Thank you. Take care.
Bye bye.
Folks, it's or I don't know what's happening with the Docker tech stuff. I'm currently, doing a remapping for that, like running an administrator and checking for that troubleshooting its error. So while it's happening, I'll just tell you guys about I've discussed about the ECR one, right? Like how Elastic Container Registry in AWS is can help you store the Docker images. I'll just simply tell you about ECS. So I guess most of you are like familiar with ECS. It's Elastic Container Service. So Elastic Container Service is also a service is provided by AWS. It is also help us like used to run and manage Docker container on AWS. So basically, what we need to do is we just define what container we want to run from your Docker images in ECR. So and ECS can easily handle the organization, like managing how and where those containers can run. So basically, we have these wonderful services offering by AWS, that is ECR and ECS, where we can store our Docker images, and ECS is used to run and manage the Docker containers. So also there's another service is Ultimate Super One. It's a Amazon Fargate service. I guess many of you are similar with it. So Fargate is like complete also a greatest benefit because it's a serverless option for running a containers with ECS. So with ECS, you don't have to worry about the managing servers because it's completely serverless. We just have to tell AWS like we just like where to run our Docker containers. We could just tell AWS to just run our Docker containers, and Fargate will completely handle the underlying infrastructure. So I hope it was helpful tip. Well, I'm just seeing what's the problem with my daughter. So I'll just give you a preview. There's the three services: ECR, ECS, and Fargate. So ECR helps to store your Docker images, and ECS is used to run and manage a Docker container on AWS, and Fargate is a serverless option where you just have to tell the AWS to run your container, and Fargate will handle all the underlying infrastructure. Is any doubt with this? Yeah, thank you, Jeeta, for sharing this documentation. She's a cloud captain. Cloud captain is always in the rescue for that. So I'll just go through the docs for you, like she sent here. Please do refer the docs. It's completely AWS one. Yeah, I'll just show you the docs. It's not being visible. And I ordered this. Hello.
Yes, you are, Sakshi.
Sorry for that. So as I mentioned earlier, so ECS is a fully managed, yeah, here it is. It's a fully managed container orchestration service. So I basically said it earlier. It's like efficiently deploys, manages, and scale the containerized application. So and also in ECS, there's this thing called as clusters. I know if they mentioned here in this document. Mm, I'll just go to it. I'll just tell you guys in like the words. So basically, what a cluster is. So cluster is a logical grouping of resources. There's this ECS clusters, which like EC2 instances of Fargate, you deploy and run your containers. So I'll just show you like if there's anything available for the clusters on.
Okay, so hi. So until Sakshi returns, why can't we have a small Q&A session? Shall we? Okay. So okay. So what is the command used to remove the image?
Docker RMA.
That's correct. So to remove the image, I said one condition to be satisfied. Can you please say that?
Before removing the image, the Docker content has to be in a stop state. Then only we can able to remove the image.
That's absolutely correct.
Absolutely
Thank
correct.
you.
Thank you.
I said that we can able to name the Docker container as per our wish. Can you say what is the command used for that?
Yeah, iPhone name.
Okay, correct.
Okay, correct.
I want
I want
everybody
everybody to
answer the
answer.
questions so that it will be very interactive until Sakshi returns.
So guys, I'm back. Sorry for the major inconvenience. So finally, my doctor text was done. There was Mona. Sorry for taking over. I'll just complete the dockerization of the React application if it's okay with you guys. Is it all right if I take over, Mohana?
Yeah, no problem, Sakshi. Continue.
Yeah. So yeah, I'll just now present my screen to you guys. Okay, is my screen visible? Okay. So yeah, finally I did some troubleshooting stuff and my Docker engine is running. So always make sure when you want to run any application or front end backend, make sure your engine is running, or else there will be a lot of errors showing. So yeah, so we left with this command. We just built a Docker file. So after building a Docker file, so I just gave a like the basic npx create react type, right? So it's with the basic JS it's having. It will basically show like the normal React application one. So as the time is up, I'll just proceed with this one only. So what I'm gonna basically do is I'll start a new terminal and I'll show like what is the command which Mohana said to you to run the Docker, to build and run the Docker image, Docker container. So I'll just in the online platform, yeah, I'll just yeah. So there's as she mentioned earlier. So to build a Docker file, the command is going to be Docker build -t. And so I did basically did a React app. So I'll just go on with my React app. So if I just run this, all my Docker images will start building. So you can see my image is up built. Yeah, it's my image is built. So now I have to run my Docker container. So what I'm going to do is for running the Docker container, the command is simple as it. So it's run Docker -p, which is for publish, like the to match code. So we know that the so a quick Q&A. So, what do anyone of you know? Like, what is the code for running the app, React app in your app, the local one? I just mentioned in the code already. Do anyone have to answer it? Okay, I'll just proceed then. So it's basically to run a front-end application, we'll get the 3000 and we are running it in the engine. So the port number will be 3000 is to 80. So I'll just redirect it to create my React app. So I'll just say create my React app. I'll just run it over. So basically what this command does is it will run the Docker container which I have built before. Yeah, so it's in the process. So now we check means, yeah, so see a container is created with the port of 3000 is to 80. So here we can access it through this local host. So if we go to, it will direct it to my React app. So basically this is the React app which created through the npix React app command. So it's a reactive one. We can also redirect to it. We can also edit this one. So I'll show you how to edit this command. For example, so this is the one. Here they have given the link also. I'll just add a two or more line. Uh, you can also say hi everyone. I'll just say thank you for your patience. So now it will be changed again. So if I run it now, okay, sorry, I didn't pull it one. Yeah, so it's basically giving the same thing. And I'll also show you. So this is the basic one for running, containerizing your front-end application. As Mohana mentioned earlier, I also did a project where I'll show you guys. So it's a long one, but I'll just explain you guys quick, like what is in it and how I did the project stuff. So I'll just go with the React one. Yeah. So I created the same application using npx create React app. So I just changed it one. So it basically asked for the DOB and stuff. And also this is the front end of my thing. And I also done a backend stuff. So where the backend folder will be here. So you can see there's two different Docker file for it. And there's a Docker compose file which Mohan has mentioned you earlier. So basically, if you have created two files, there is a backend one and a front end one. You need to separately run these two commands, right? So this is the backend and front end command for that. So what we do is we write a Docker compose file through which I can easily access to my. So you see here I have mentioned this is a front end, and I have also written the code for backend and my MySQL stuff. So with this Docker compose file, I will just explain it in the next class following because we'll just stop it for the front end in the first session of our class. If we get a time and if the time permits, I will just take you into how to completely Dockerize a React application, a full stack React application. But for now, you just see this thing. So the front end port will be running on 3000 is to 3000, and for the back end, the port number will be 5000. So I just used the MySQL database. So for that, it will be 306, 3306 will be the port number for it. So I'll just show you guys how to run it. So it's here actually. I just named my container also. I'll just show you. I will just manually run it because I don't know if it's going to run. Yeah, it's already running. I'll just stop this one. Go and see. Yeah, there's a problem because 3000 is not running because I already have a container with 3000. So I'll quickly delete this one because in this we can't run both 3001 in same time. So I'll just manually stop it and on it again. So I'll put a comment to it. Yeah, it get exceeded. So I'll just tell you guys the command also to run it. So there's this command called docker compose. This is for to run the Docker Compose file. So it's the Docker Compose build. It will start building all your applications, like all your containers, the front end one, the back end one, and the MySQL container. It will take a quite a few minutes, I guess. Yeah. Okay.
மீட்டிங் போய் பாத்துட்டு தலை வலி ஒரு பக்கம் தலை என்ன வச்சிருந்து போன கல்ல அதான் வலிக்கிறாரு.
Bhavadharani, can you please mute yourself? Sorry for the inconvenience. Thank you. So it's creating, basically it's building. There's also this command to build and run the Docker container, Docker Compose in the same one. So I will also have to do that, but I just gave Docker build. So do bear with me. I'll just show you guys the other one also. It will take quite some time. Yeah, so my Docker container have been built. Now I'll use this Docker Compose up, so it will help my containers to run. Yeah, so we can basically see all this have been created. Now we'll check thing. Yeah, three of three is servers running. Uh, I'll definitely show you guys how to create the full thing in the next class. So I'll just show you the front end. It's also a basic one I created. I'll just show you like what is happening. Where is a problem? Wait. Yeah, front end is completely ready. There's a problem. So yeah, basically that's all about how this to the Docker Compose file also works. You can see all my three containers are running. So with the single command of Docker Compose build and Docker Compose up, you can easily build and run all the three containers in the same time. It can also apply to many of the containers which you're going to use. So yeah, next part of our session will be about the how AWS and Docker are integrated. So now we'll come to the part where I already told you guys about. I'll just- Yes, sorry, I didn't notice you raised your hand. Yes, sir. Saulos. Yes. Any doubts?
Yeah, just wanted to check out of the box question, I could say. Like, if you can let us know, like, if the Docker is running, right? I might think like we can have multiple Dockers in our server. So the
Yes.
Docker might get overwhelmed. Sometimes it might use your 8 GB of RAM. It might use your 16 gigs of RAM. That might happen. So how come we limit the resources like the CPU and the memory? If you can guide us through.
Sorry, sir. Can you please again? I'm not.
I just asked, like, if you are running a Docker container, so
Hmm.
it is unrestricted, right? So it can use 16 GB RAM, it can use 4 GB RAM, it can use like 6 CPU, 4 CPU, anything. It is unrestricted. But if we want to restrict it, how come we restrict that? That's what my
Uh,
question is.
mm,
If it is not feasible, so you can like skip that.
yeah, sorry for that. Like currently, I'm working in the POC stages. Like I started going with simple projects. I'm not,
No issue.
that much familiar with how to restrict the GB also, but I'll
No
for
issue.
sure update you for that.
Yes, you can give your try. No issues. Thanks.
Uh, yes, actually, that's actually a pretty good question. I'll definitely check through like how it will work also. Thank you
Sure.
for that question.
My pleasure. Thanks.
Okay. So quickly, I'll just go give a brief introduction about like not an introduction. I'll just go through like what AWS Fargate does because we have been talking about Docker and stuff and how Docker is good, how we can build and containers and how to run images. So I'll just share you the links like already. Captain have shared the links. You can check it in the mailbox. There's a link for AWS ECS, ECR, and Fargate. So kindly go through it. But I will just give you a brief intro about what AWS Fargate is. Uh, so as I mentioned here, it's a serverless compute. So it's serverless compute means no server management is required. So basically, what it tells us, we don't need to provision like any or manage any EC2 instances because to run anything, first we need to create an elastic like EC2 instances. Then we need to specify what it's doing. So since it's serverless, we don't need to provision or manage any EC2 instances to run our container. And then one is it's also it has the auto scaling feature available. So what this auto scaling feature does is so this Fargate, with Fargate you can easily sorry, with Fargate, you can easily scale your containers based on your demand. So if the demand is high, you can easily scale up and scale down the requirements of you according to the traffic. So next one is obviously AWS is famous for it, it's known for it. All the cloud computing providers are known for it. It's pay per use. So that's about the AWS Fargate. So I'll again repeat, it's a compute engine. It's a serverless compute engine where we can, run the Docker container with simple commands by running it. So it basically works with Amazon ECS and EKS. It's an Elastic Kubernetes service with help of Amazon ECS and Amazon EKS. It runs. So talking about Amazon ECS, I will also take you all through the documentation. I'll just uh, scroll it through it. You can look into it afterwards. So I'll just go through like what Amazon ECS is. So here it is. You can go through it. It's having how all the stuff is working. So they are also providing the easiest workshops and tutorial like how to do the task. So yeah, here it is. So basically, we'll just see like what is ECS is. As I said earlier, it's a fully managed container orchestration service. So basically, it's used for cluster management. ECS is mainly used for cluster management, as its name suggests. It's a container orchestration service. It is used to easily run, stop, and manage Docker containers. So I'll just give you a breakdown of how ECS works. You can later go through the docs. So first comes is cluster management. So what ECS does it lets you create a cluster. So a cluster means it's like a group of EC2 instances where container runs. So that's it. ECS helps in cluster management. Then the next part is the task definition. So you can define container settings like what Docker image you need, then the memory you require, and the CPU requirements can be defined through Amazon ECS. So it's a help for task definition. Then there's service management. Also, because yeah, service management comes the important part of all the services we have been using. So in the service management category, so ECS easily manages the scaling, health checks, and load balancing of the container within your cluster. So that's about the ECS. So yeah, again, it's the link is provided in the mailbox. You can check through it. Yeah, it's here. So the capacity, the infrastructure where you run your container, it's basically a simple one. They also provide you, AWS also provide you tutorial of how to, run a Amazon, like the normal Docker run container, and you can push it through it. But the time is not sufficient today. So the next class we will I will definitely go through like how to push the Docker container using ECR or forget register. So I think that's all for the today's class from my side. So if you guys have any doubts or if you want to contact, you can definitely raise your hands and ask for it. Thank you. Any doubts, guys?
Uh, Actually, am I audible?
Yeah, sure.
Yeah,
Yes,
sure.
yes.
Okay. So as you said that the Docker can be integrated within AWS, right? So can we prefer a choice like launching an EC2 instance, and can we make this as a self-hosted Docker there, or we need to prefer for the ECS, which is a preferred one?
Your voice is
Your voice
breaking.
is breaking.
Okay, am I audible now?
Yes, yes, yes.
Yes, yes, yes.
Okay. So what I have asked is, is this a service where we can make use of an image and we can run the container. So instead of that, instead of Fargate and all, we can go for an easy to instance launch type, and with that we can install a Docker directly in the machine, and we can run the image from there, right? So can you give me an example of how it differs and which one need to be preferred?
Okay, so if
Okay,
I'm not
so if I'm not
wrong, you're basically
wrong, you're
asking
basically asking
whether I can
whether
run
I can run.
No, actually, we can run a Docker in the EC2 instance itself.
Yes, yes.
So, yeah, as you said, that the Docker can be integrated with the AWS service. So, that integration part, I'm asking whether you're referring to be installed that in a particular EC2 instance, or the best part you're going with the ECS and that part.
So I'll tell you what I
What
so you
So
prefer
you
like
prefer
based
like
on
based
the
on the
use
based on the
whether you use
whether you
EC2
use
or
EC2 or
it depends on your
depend on your
use cases.
use
So
cases. So
as far as
as
EC2
far
is
as EC2
concerned,
is concerned,
it is
it
cost
is
conscious
cost
because it's
conscious
cost
because it's
efficient
cost
and it
efficient
is
and it is
your container to be
considered to be
running
running.
and you have to
You have
perform
to
your
perform
workload
your workload
for
for
EC2.
EC2.
But
But
for the
for
party
the party
is concerned, if the
concerned,
task
if the task is
the container
the container
startler, which
startler, which
you can preferably
preferably
it needs to depend on what
on what
use case
use
required.
case required. So depending on the use case, you're saying, right?
Yes,
Yes. Okay. Okay. Thanks. Thank you.
thank you so much.
Thanks.
Any other question, folks? Okay, I guess that's all. So thank you for Diana. Can we wrap it up if it's good and nice? Any other question?
Yes, Sakshi, sure. Just a minute. I think if there are no questions, then we can conclude the session.
Yeah. Thank you, team. Thank you.
Yeah,
Thank you
sure.
for your questions, Sonia.
Yeah, thank you all for joining us today. A special thanks to our speakers, Sakshi, Ravi, and Mohana Priya, for an insightful session on Docker and AWS. Your expertise and passion have truly inspired us. Thank you to everyone who participated and made this event a success. We look forward to seeing you at our next workshop. Thank you, guys. And before you all leave, can we have a group picture? I request everybody to turn on their cameras, please. Guys, please make it fast.
The club members are requested to turn on your camera, please.
That's okay. That's not a problem. We'll just conclude the session. Thank you all.